So today we are looking at using the nth term. And as you can see there, we are finding the first 5 terms. I have got a separate video about finding the nth term, so maybe it might be worth looking at that first. But here we're going to be given an nth term, which is 2n plus 3, and we have to give the first 5 numbers, or the first 5 terms of this sequence. Okay, so this n, this n stands for the number of the sequence. Okay, so we're going to be looking for the first number, second number, third, fourth, and the fifth. Okay, so basically, for each of these, n is going to be represented by this number here. As I said, that n is the number of the sequence. So for the first term, n would be 1. So now it's just a bit of substitution. And I'll be honest, all of these questions is all about substitution. Again, there's another video on substitution. You could look at that if you wanted to, but I'll go through all the steps and all the parts that you need in order to get this correct. So if n is going to be 1, okay, I'm going to substitute the n for the 1, which means 2 times 1. Then add the 3. Well, 2 times 1 is 2, plus 3 is 5. So my first term of the sequence is 5. This time, the second number of our sequence, or the second term of our sequence, will be when n is 2. So this time, it'll be 2 times 2, plus 3. You can see here, all that's changed is the 1. Okay, the 2 is still here, and the plus 3 is still on the end. So 2 times 2 is 4, plus 3 is 7. So my second term will be 7. For the third term, we have 2 times 3 plus 3. 2 3s are 6, plus 3 is 9. Here, the fourth term will be 2 times 4 plus 3. 2 4s 8, plus 3 is 11. Fifth term, 2 times 5 and plus 3 to make 13. Okay, so my first 5 terms are 5, 7, 9, 11 and 13. You'll notice they are going up in 2s because it is 2n. So a similar one here now. We have 5n take away 1. So let's have the first term then. Will be 5 times 1, because n is 1, and then subtract 1 on the end. So 5 times 1 is 5, take away 1 is 4. Now the second term will be 5 times 2, and then take away 1. Well, 5 times 2 is 10, take away 1 is 9. You will see here, we've got a difference of 5. It's gone up by 5. Third term, we're now going to substitute the n for 3. So 5 times 3, take away 1. Well, 5 times 3 is 15, take away 1 is 14. You can see now, again, we've gone up in 5s, because this is the coefficient of the n. So let's add on 5 here then, to make 19. Let's add on 5 to make 24. There are our first 5 terms of that nth term there. So now, exactly the same, but this time we have that squared symbol. Okay, so that squared symbol means multiply by itself. So the first term is going to be 1 squared, and then add 3. 1 squared is 1. Plus 3 is 4. For the second term, this means it's now going to be 2 squared plus 3. Well, 2 squared is 4, plus 3 is 7. Third term will be 3 squared plus 3. 3 squared is 9, plus 3 is 12. Okay. This one doesn't work with that pattern of adding on each time, okay, because of this squared symbol here. That only works when there's no squared. We call it a linear nth term. This is quadratic because of that squared element. Fourth then will be 4 squared plus 3. 4 squared is 16, add the 3 to make 19. And then the last one, when n is 5, we have 5 squared and then add 3. 5 squared is 25, plus the 3, 28. So here are the first 5 terms. Right, these are getting more and more difficult. Okay, this one here. Yes, it is very extensive, it's more higher tier now, but using substitution, we can easily work out our first 5 terms. So the first term is when n is 1. So we have 3 times 1 squared, which is 3n squared here. So I've got 1 squared, but then after that then, I've got 2 lots of 1. I'll put a bracket around there. Okay, and I'm also going to put a bracket around there. I then got plus 5. This just makes sure we can keep these parts together by using the brackets. Okay, so now I've got like a BODMAS or BIDMAS question. Well, 1 squared is 1, 3 times 1 is 3, plus 2 times 1 is 2, plus 5, which is 10. So our first term is 10. Second term, 3 times 2 squared, because n is 2, plus 2 times 2, because n is 2, plus 5. 2 squared is 4, 3 times 4 is 12, and 2 times 2 is 4, plus 5. 12 add 4 is 16, add the 5 to make 21. Now be careful with this bit here, okay, because you'll notice that I've automatically gone to the indices. I've gone to the squared. 2 squared is 4, okay. That is the correct way of doing it. I know for a fact if I gave you that question and asked you to calculate it, a few of you would tell me 36, okay, and I can see where you've got 36 from, because you've done 3 times 2 is 6, and then squared the 6 to make 36. However, the squared element is only on the n. It's not 3n squared, it's 3 lots of n squared. Okay, so be careful there. That will need a little bit of practice. Let's have a look at calculating our third term. So this time I've got 3 lots of 3 squared, because n is 3, plus 2 lots of n, but n is 3, and then add 5. Well, 3 squared is 9, 3 nines are 27, plus 6 plus 5 to make 38. Okay, bigger numbers now, a lot more substitution, but we can get there. So fourth term, let's go down here. 3 lots of 4 squared plus 2 lots of 4 plus 5. 4 squared is 16, 3 times 16 is 48, 2 times 4 is 8, and then add 5. And it's like 61. And then the last one then, fifth term. Got 3 lots of 5 squared plus 2 times 5 plus 5. Well, 5 squared is 25. 3 25s are 75. 2 times 5 is 10. And then add the 5. 75, 85, 90. Okay, so we have 10, 21, 38, 61 and 90 for our first 5 terms of this very complicated nth term. Remember, the biggest key to this is substitution. Okay, hope it helps. Have a good go, but again, with everything in maths, it takes a lot of practice. Hope it helps.